Okay, so this is video number 3 for lab 1. And in this video, I aim to show you how to georeference the Prism data um, that we collected from the Prism website as an image and give it real world coordinates just using one of ArcGIS Pro base maps. But I would also want to remind you that we hopefully downloaded the ASCII grid file as well. And so here it is in my folder, Prism PPT 30-year normal 800-meter annual precipitation as a zip file. I right-clicked and clicked extract here under 7-zip for me. You could use another zip file program, but yeah, so there it is as an ASCII grid, and I can then see that here, and I can load that into ArcGIS as a data set by, I'm not sure why it's not showing up yet. Let me zoom to layer. So there it is. It looks a lot like elevation because precipitation goes with elevation. I can also see that the values range from 45 to over 6,000. So I know that's not in inches of precipitation, but millimeters. So we'll have to do some raster math to comparison to inches. And also we'd want to change the color scheme to compare other gridded products or our interpolations that we're going to do later in the lab. But for now, we're not going to worry on that. So I'm going to turn it off. And I'm going to zoom back into Utah. And we can see in the background my Utah normals. I'll turn those off for a minute. So there's my state of Utah. And we're going to georeference to those edges, basically. And what are we going to georeference? That Utah Prism data. So zoom to layer. I brought that in. It's floating off in space somewhere because it doesn't have any coordinates. You can see that the shape of this state of Utah is a little bit different than this state of Utah. I don't know what coordinate system this map was produced in, but it looks to be expressing more of the curvature of the Earth. And yeah, it looks a little narrower at the top and wider at the bottom. So recognize that as we do this georeference relative to the coordinate system that I'm in here, which is probably the Webb-Mercator coordinate system, we could check on that. So if I go back, I right click here, I click properties of map. Right. There's the Webb-Mercator right there. So then if I zoom back to this, we can see that it's clearly not exactly that, but I haven't had good luck figuring out what exactly coordinate system matches well. It would be helpful to do that in order to get the best georeference possible. But nevertheless, if we don't get it in quite the right coordinate system, you're going to have some distortions. That's okay, but you should know it and realize that's part of it. Okay, so here's this file. We need to georeference it. So if we go, so if we go click, we go zoom to layer. Yes, we're there. Okay, so we click on imagery, and in the imagery tab, there's this tool right here, georeference. Click on that. And then it brings up the georeferencing pane. And there's a control table, which I can turn on. Don't need that much of a control table. I have no points yet. And then the other thing, if we go back to map, I can go back to my map, forward to here. That's nice. And my georeferencing tab is there. So I'm going to add a control point. So whenever you're doing georeferencing, remember the first place you want to click is on what you're moving. So you want to make sure you're on the image that you're trying to bring in. You want to get a good corner. So here we're going to use the state boundaries, and that's as good as we're going to get. Okay, so I'm going to zoom right there. I've clicked, but didn't quite catch it, so I'll click again there. Now I know I've got it. I'm going to go to map. I'm going to back up a bit. I have to back up a few times now because boom, but now there I am, and I want to tie it to this point right here. Okay. Wow, there's a tiny little postage stamp. That's it. Let's zoom to that layer. So there it is. Now we're going to get this other corner over here. Okay, and I'm going to back up. And I got to zoom out now because I'm so small. And I got to zoom over here, the state line, and click. Okay, now things are looking pretty good, but not great. There's some other issues. Let's start over here. So now we get this edge. Then we can turn this one off. We can see we're off here. So that wants to be down there. We're starting to introduce some distortions. Now I can get all these edges, right? So I can click, turn off, click. And you can see what the residuals are in terms of my coordinates on the map. Those are big numbers, but it's not looking bad. I'm not sure. Those must be in meters. It's kind of weird. Okay, so let's get these bottom corners. Off. There. Turn it back on. Four corners. Okay. Not perfect. But we're not going to do much better than that because those are the corners we got. Now, we have 6 points, and that means we can do a little bit more than what I've done right here. So let me just look at this broadly for everybody for a second. So we can turn this on and off, and we can see that I haven't done so bad. It looks like it's in the state of Utah. There's a bow to it. It's not a straight line down here. You know, we knew coming in there was a slightly different coordinate system, so we really need more tie points to get things perfect. Maybe we can do that if we like zoomed into the river here. You know, we can see that state boundary or something. So I could say, oh, there's where that arm meets right here. And I'd get another little point, right? But it's still not solving everything. But I get 7 points now, which means I actually can go to a higher order polynomial, which will allow kind of more distortions than just linear. So first order would just be like a linear stretch. So this should make things in some ways look better. Outside of the image, maybe not, but perhaps within it does look better. One way to tell that would be to maybe make this thing somewhat transparent. So I think if we go to appearance, we can make it a little you know, that ain't so bad. Look at Utah Lake there. It's kind of in the right spot. So is the Green River. I don't feel so horrible about that. So I'm just going to leave that as is. So I did a second order polynomial. It had these kinds of hundreds of meters of residual error on there. And so I'm going to go back to georeferencing. I'm going to save. And that should be it, I believe. And I can close georeference. It should stay there. Okay, so that's my georeference image. Okay, so I guess I'll just wrap up with saying this. So what did we see? So we knew we are going to have to do some higher order polynomial to get a fairly good fit, because we could see the coordinate systems weren't quite matching, or their projections were slightly different. We did get enough points to do a higher order polynomial fit. We saw hundreds of meters of residual error, which is not great if we were going to make calculations from this image, but we're just using it as a visual product, so it's okay. And hopefully you learned how to quickly kind of rubber sheet georeference something to the map for visual comparison. If we're going to do higher sort of precision georeferencing, we want to really careful about what coordinate systems we think the incoming map is in and try to line that up. That might take some research. We don't have time for that, and that's not what we're doing right here. Okay, so we'll stop this video.